I'm Morgan, and today we're going to do some science experiments and activities that focus on fun physics concepts. These activities are best for students grades 3 through 5, but are really fun for people of all ages. And the lessons we're going to do today focus on 4 physics concepts. Those are laws of motion, states of matter, sound and waves, and magnets. In our first lesson, we're going to talk about magnets. And to study magnets, we're going to build a compass. It doesn't take very many things to build a magnet. All we have here is some water, regular sewing needles, Sharpie, a piece of paper that's been laminated, cut into the shape of a circle. There's a little pottery dish, regular tape, 2 magnets, and I have a phone here, but I'm using it because it's a pre-made compass. So the first thing that you're going to do is take your circle. I made this by cutting a piece of paper into a circle and then laminating it and cutting it out. You're going to take the sewing needle. I'm going to take 2 because these are kind of thin. And you're going to tape them across the diameter of the circle. I'm going to do that now. You want to tape them together so they look just like one by just simply laying a piece of tape across the middle. Ta-da! So then you're going to take, this is a regular magnet. I bought it from a magnet set called Geomags, which are very fun. And you're going to run your magnet across the needle about 25 times. And what you're doing here is you're aligning the atoms inside the needles so that it becomes magnetized, just like this. It's really important that you only run the magnet in one direction, not back and forth across the needle. So what we're going to do is we're going to pour some of the water into this little clay dish. You don't need a lot, just a little bit, like that. And now we're going to take our circle and float it in the water. Alright, so now we've got it. It's got it right here. And so compasses, they always point north to the geological North Pole. So we want to make sure that our compass is pointing the right direction. To do that, I'm going to use the compass on this phone. So my phone compass is telling me that north is just about straight ahead, just like the compass says. So now we know that this is the north end of the compass and this is the south end. It's really important that you figure that out because you won't know unless you check it with an actual compass. Label it for your own purposes. You'll know north is here, south is here, west, and east. And so now you can float it back. Compasses that you make like this only stay magnetized for a couple of hours at best. And if you introduce another magnet into the situation, it will change the direction that your compass is facing. And see, this one's still good. It's realigning itself with the direction it should be facing. Right here, except for overshot. There we go. Another way to check if your compass is, which end is north and which end is south, is if you have a bar magnet that is labeled north-south, then you can check it by lining it up. If I touch the north end to what we've already determined as the north end, it's going to spin around so that north aligns with south, or south will spin around so north and south align. Because with magnets, opposites attract. So that is how you make your very own compass, and again, it will only last for a couple of hours. Now we're going to talk about waves. We're going to make string telephones to examine properties of sound waves. We're going to use a slinky to show the 2 different types of waves, longitudinal and transverse. String telephones are very simple. They only require string, 2 plastic cups or tin cans, a needle, this is just for how to make them, scissors, and some tape. So the first thing you need to do is take a piece of string, really any type works, and thread it through your needle. All right, then you're going to poke your needle through one end of the cup. Push it all the way through, and then pull it through on the other side. After there, you can take the needle off, and you're going to tie this end of the string into a knot. But most of the time, the knot still wants to slip back through the hole, so you can use a small piece of tape around the knot to prevent it from slipping back through. Ta-da, that's it. You can pull that through, just like that, to make sure it stays. Then you can determine how much string you want or how much distance you want your telephone to cover. I think about this much works. Just like before, you're going to thread this piece through your sewing needle. Perfect. Then you're going to thread this needle through the other side, or the bottom of the other cup, just like before. Pull it through on the other side. And tie it off just the same. Alright, now you have a telephone. Now that we've made our string telephone, I'm going to show you just a few ways of how to use it. First thing you do, when you use it, you and your partner, you stand back from each other and you have to make sure that the string is tight. You don't have to pull violently, but if it's loose like this, it will not work. The sound waves have to be able to travel through a straight and medium like this. So one person is speaking into it and the other person's listening. When I'm speaking, my partner Harrison is going to cover up his other ear, just so he doesn't accidentally hear what I'm saying on this side instead of through the phone. And all I have to do is whisper into the cup. Can you hear me?
Yeah, good.
It works very well. You don't have to yell or shout, but it's very important that you keep the string tight, otherwise it will not work. Another thing is if you're trying to speak around a corner or around a bend, just like this. All right, back up just a little bit. And the string is bent, it won't work like this in any way. Or if you're pinching it in the middle, they stop all the waves and make it impossible for him to hear me. So there are lots of fun applications of the string telephone. Now we're going to use a regular metal slinky to demonstrate the two different types of waves, longitudinal waves and transverse waves. So you hand one end of the slinky to your partner and get a big distance from each other. First thing we're going to do is demonstrate longitudinal waves. To do that, one person, Anna's going to keep her end flat on the table and not moving. And from my end, I'm going to send pulses down because longitudinal waves are made of compressions and rarefactions. And so if you send them down in pulses or periodically, it will represent a longitudinal wave, just like this. Both people send a pulse down at the same time, and you can watch how they collide in the middle and then bounce back. All right, 1, 2, 3. Now we're going to look at transverse waves, which are made by displacing things vertically, up and down, instead of back and forth, horizontally, like longitudinal waves. So to show that, both of us are going to very lightly move our hands back and forth with the slinky. Now we're going to talk about the 3 laws of motion. The first activity will deal with the first law of motion, and our second activity will deal with the third law of motion. This activity deals with the first law of motion, which states that an object at rest will remain at rest, and an object in motion will remain in motion. This activity specifically focuses on an object at rest remaining at rest. All you need is a cup, a playing card, or really any piece of paper, and any type of coin works. So you take your card and place it on top of the cup, and then place a coin on top of that. So what you do is you want to get level with the card, just like I am now, and you're going to flick the card out, like straight out from underneath the coin, like this. Now as you can see, the coin remained where it was. The object at rest remained at rest. You can try this with multiple cards, multiple stacks of coins, just like so. It's a little trickier, but it still works as long as you flick them straight out. And this is the same thing as when a tablecloth is pulled out from a set table. It's the same idea, just a little easier to do. Now we're going to do the classic Coke and Mentos activity, which doesn't directly show the third law, but will be used in later activity to show the third law clearly. First thing you do, open your Coke bottle, and dispose of the cap. Then you're going to take you can use a funnel. This is just one I made out of paper, rolled it up and taped it. Works perfectly fine. You're going to open up your Mentos, and you're going to pour your Mentos into your funnel, just like this. You don't need the entire roll, but I think the entire roll does well. So you're going to position your funnel right over the Coke bottle, but with a card in between it so the Mentos don't come out. Then, when you remove the card, make sure you're ready to back away quickly so that you don't get Coke on you. law of motion states that for every action, there will be an equal but opposite reaction. To show this, we're going to use our Coke and Mentos explosion and attach the Coke to a skateboard. This will show that the action of the Coke shooting out the back of the skateboard will cause a equal but opposite reaction to propel the skateboard forward. The first thing you're going to do is take your bottle of Coke and tape it to a skateboard, but make sure that the end of the Coke bottle faces out the end of the skateboard. That'll be plenty of tape. And what you're going to do, this part is a little tricky, is to get the Mentos, drop them into the Coke. You're going to prop the skateboard up like this. Open the Coke slowly. And you're going to pour your Mentos into your funnel. Again, make sure the bottom of your funnel isn't open. Alright, now this part is very tricky because as soon as you drop your Mentos in, you want to make sure you drop the skateboard and move out of the way so it can be pushed forward. Now we're going to be talking about states of matter. And a great demonstration for states of matter is dry ice. Dry ice is frozen carbon dioxide and can be bought at your local grocery store if you're 18 years or older. And dry ice is very dangerous. Gloves must be worn at all times when handling dry ice because it is about negative 110 degrees Fahrenheit and can cause severe burns. So I have a bag of dry ice right here, and I'm just going to remove a piece from the bag. There we go. It's just a small chunk. Dry ice is unique because it goes directly from a solid to a gas. There's no liquid form of carbon dioxide. If you breathe on it or add more heat, you can see a lot more gas. Dry ice has some very other interesting things that you can do with it. If you take regular food coloring and drop a few droplets onto the dry ice, observe what happens. As you can see, when in contact with the dry ice, the liquid food coloring essentially freezes while it runs off and then turns back into a liquid once it's off of contact with the dry ice. Now, one fun thing that I always like to do with dry ice is to take some regular tap water into a cup along with some regular dish soap. You don't need a lot. Set that on in. And then to drop in a small piece of dry ice, one even smaller than I have there. This size works perfectly. And watch what happens when you drop it in. Now, there are bubbles coming off the top, and it's okay to touch these bubbles, and as you can see, carbon dioxide gas is what comes out. There are other little tiny bubbles here, and those are regular soap bubbles. The majority of them are carbon dioxide. And since carbon dioxide is heavier than air, these bubbles, they sink down instead of floating up like regular bubbles might. And they drain off. A fun thing to do with kids is to drop in a little bit of food coloring, and it makes the bubbles look all the more interesting. And it's totally safe for anyone to touch them and to see the release of carbon dioxide. Now we are going to make ice cream. This is a very popular activity, but is kind of complicated and has a lot of steps. What we do is we combine the ice cream ingredients, and they're in liquid form, and we lower their temperature to their semi-solid ice cream state by using a combination of regular ice and rock salt. This works because rock salt can lower the freezing temperature of ice. So at the end, the icy mixture is about 14 degrees Fahrenheit instead of 32, where melting ice would normally be. So, first thing you need is about a quart-sized Ziploc bag, and you're going to combine 3 things in the bag. First thing you need is 1 tablespoon of sugar. So, regular granulated sugar works just fine. There you go. 1 tablespoon of sugar, 1/4 of a teaspoon of vanilla, and then 1/2 cup of half and half. Heavy whipping cream also works. Now, this is a very important step. When you seal your bag, when you want to make sure you seal it really well, you need to suck all the air out of the bag so that it's completely airtight. If you skip this step, you have very small chances of successfully making ice cream. Just like that. So now you have your ice cream mixture. These are all the ingredients you need. This is just going to make vanilla ice cream. And so now you have a container. And you want to fill your container with ice. Just regular ice works just fine. Alright, so I got about almost all the way full with ice. And then you're going to take rock salt, which is really simple. You can buy it at the grocery store. And you're going to take 6 tablespoons of rock salt. Alright, you're going to set your bag into this. See if you can get any more ice in there. You want to make sure you have as much ice as possible in your container. You're going to seal up your container. And let's see. I always like to use tape to make sure it is extra sealed and there's no chance of that lid coming off while you're shaking. Alright, so now you have all your ingredients in your container and you're ready to start shaking for 10 minutes. Alright, now we're going to cut our ice cream out after 10 long minutes. It's still very cold to the touch. As you can see, the top of this container has essentially frozen over. And on the outside of your ice cream bag, it's going to be kind of like a watery, salty mixture. And let's see. There we go. This is about what it's going to look like when it comes out. But it's congealed. It's very hard. You open it up just like this. If you can see, there is good old American ice cream on the inside. And I got a spoon right here. And you can eat it right out of the bag if you want. Just don't want to touch the outside because it will taste kind of salty if you do. Delicious. Alright, well those were our 4 lessons. Thanks for watching.